All right, so in the last lecture, we have covered Google Sending. I give you a brief introduction about how to use it. Oh, by the way, so for Lab 9, is about doing some of those assignment using leaf map. You don't have to implement the functionality in your package. You can just use leaf map. So for the last two lectures and today, we're just showing you some of the things you can do with this kind of open geospatial tools. You can certainly steal some of the ideas and implement in your package, but it's not a requirement for Lab 9, okay? You can just use leaf map directly to do the assignments. Unless you really want to, you can certainly integrate some of the functionality that you see might be useful for your package. Then you can maybe look at the source code, see how it is implemented. Then you can adapt the source code to your package. But you need to make it work if you want to do that. So, and for today, we want to continue Google Sending. So I'm going to skip to the section. So we have covered the basic introduction. So I'm going to maybe go to the Earth Engine Data Catalog. So we briefly mentioned this one in the last lecture that Google Sending allows you to actually source the data interactively, and you can just over here. Might need to okay. So something like this, and you can use the Google Gmap dataset module, do it like this way. I think this one is not used very often, but you can certainly just create a map and then just image or image collection, and then have the URL. So this one basically under the hood is just a string representing the data. So if you want, you can just do it like this. Okay, data dot blah blah, and if you run it, this one basically behind the scenes just like this. The reason that we have this is to make it like you can have autocomplete. So for example, data, and then you can pop a whole list of the entire Google Sending data catalog. So in that way, if you don't remember the details about the data set, but you remember the first couple characters, then this might be something useful, right? So you can just type data and then you can see the entire list. For example, maybe NASA something. I know it's coming from NASA. Then you just type NASA, and then from here you can basically find the list, basically the autocomplete list. For example, okay, I want the Landsat 8 collection 2, top of the atmosphere. Then you can just write this, okay? But if you already know the exact name, you can call the name. But if you don't know, then you can use this one to load the data. So this is one way you can do that. And you can also get the metadata similar to what you see from the JavaScript website. So if you click the link, it should take you to the website just like this. So it's exactly the same, but you can do that in Python without having to go online to source everything. So for Google Sending, we have image, right? And you can just type the name of the variable. Then you can print out quite a nice representation of the data, just like what you see from the website. So I would like to show you the differences in here. So make sure that you understand. So I'm going to create a new code block, right? If you just type the name of the variable, you're going to see this. But if you just use the function, use the print and then image, this one will not get you a nice representation. So again, look at these two here. Oops. So look at this image. It looks like this. But if you use the print image, it's going to look like that. And this one is basically just a representation of the image, but you don't really see any data because this one is basically just like a black box. You know roughly what it is, but inside, if you don't print it out, you're not going to see anything. So this is the recommended way of, getting the metadata is just to print out the variable. Geemap, we're able to actually give you a much better representation of the data. So don't use this way, or you can also use this one, image to get info. This is another way, but usually this one is pretty long. So you probably don't want to use this one. You can just like scroll content. It's pretty long. So if you're looking at a data set that has many information inside, it's not, it's going to take a lot of space. Okay. So any Google Sending object, all you need is just print out the object, and then inside you can have this collapsible content for you to look at the data. You can do the same thing for image collection as well, but if you have like millions of images, then it's not a good idea to print out the data directly. So similarly here, like this is an image, just print image, then you will be able to see the content. So for this one, this is entire image collection. So this is Sentinel-2 harmonized data set. And I don't know how many images in there. Right now, we just use this variable, and this one probably contains millions of images. If you want to see how many images in there, you can say collection dot size. Okay, don't run this one. It's going to take a while because it's going to loop through the entire data set. But I can certainly do it this way. I can say dot limit. Okay, and then say 10. For example, I just want to get the first 10 images in this image collection. So this is the entire image collection. So it has a lot of images. I just want to see the first 10. So if you just click run dot limit 10, and you will give it a collection. So in this way, you can see how many in there. So you can see all the data sets. So for each data set, if you click inside, you will be able to see the spectral bands. For example, for Sentinel-2, it has a lot of images, and also how many, what's the data property. So you see also it has a lot of data property. So this is a way you can get a preview of the data set using the dot limit function. So in that way, you're not printing out millions of images. You're just printing out just 10 images, and then you can see the data. So this is essentially you go into the NASA website or whatever, and then you download the data, and then you open using desktop.js trying to look at the data. So this is about image collection, but you can also do the filtering. If there are too many images, you can create, for example, a ROI, a geometry dot point, and this is going to show you, for example, how many images intersecting a particular location. And for this data connection, we have over 1,000, and then you can just stop first to look at the first imagery. So keep in mind, there are tons of data out there. So every data set collection has certain metadata. And if you want to do something with the data, you also want to see like what's the metadata, what's the resolution, what's the date, or something like that. But if that collection has too many images, you can just use the first to see basically the first one, and then look at the data. For example, how many bands, what's the name of the bands, and what's the property, right? So in this way, you can get some basic idea about the data set, what it looks like before you're trying to do some analysis. So for example, there's a cloud pixel percentage, right? So how do you know? Because the property has this one, cloud cloud pixel percentage, right? 25%. So if we just do the filtering, e.filter LT means like if the cloud cover is less than 5%, I'm going to select the data. So in this way, you're going to get a lot of high quality images, basically filtering out all the cloud. And then I can basically create a simple, get the first one. So look at this, right? So we are just filtering the data. I'm just finding out imagery covering state of Tennessee. Just one imagery. And so if you look at here, right, this is where we are. So just a couple lines of code, we can filter data, and you can find a lot of images available for your area. Just a couple lines of code without having to download anything. So if you're doing remote sensing, try to utilize this one. It's so powerful. It's going to save you a lot of time if you need to find remote sensing data, especially trying to visualize. Similarly, this one takes all the images, and then I can visualize using force color composite using the medium filter. Medium filter means you have, let's say you have 10 images, and for every pixel, every location, it's going to take the median value of all the 10 values and then get the one in the middle. So in that way, you get pretty nice, decent images that's usually cloud free, because unless you're in all the images have cloud, then the medium composite might not look very good. If it is very normal, like some have cloud, some don't have cloud, then the median composite usually is a pretty good result. So this is how you can source the data easily using Google Sensing. Questions? Okay, so e.image is a single image. E.image collection is a bunch of images. So it can be one, it can be two, it can be a million. It doesn't matter. So you can have as many images as you want. Next one about the vector data. So same thing. This one is the Tiger dataset for all the transportation network in the US. And it's an image, it's a feature collection. And I can just load this one, add layer, and that's it. So now you have the dataset for the entire US. If you're trying to download this one yourself, good luck. It's going to take you a long time. But now I can just load the data, and you can see I can have the entire dataset just with a couple lines of code compared to have to download the data. So you can also change the visualization right now that shows you just the basic, right? So you can have this kind of data from the catalog, and then you can say, okay, I want to send it somewhere, and then just load the data layer. So essentially just 2 lines of code, okay? This is the data set I want. Just add the data to the map, and that's it. Then you will be able to show it like this. And you can also select data. For example, I can add all the state for the state boundary for the US, but I can say filter, and then e.filters filters to EQ. EQ means equal. That means, okay, if the column name, the name equal to Tennessee, I'm going to select that one, and then I'm going to add that selection to the map, center this one, and now we have Tennessee, right? So can you select maybe, so how do we select, maybe for example, Florida from the data set? What do we need to change? Just the name, right? And just say Florida. And that's it. So any, I can change this one if I want to. This one is no essential. It's just Florida in here. Run it. See, so I select Florida. This is super powerful. Everything runs on the fly. You don't have to download the data. You can do all the query. And this is the so-called cloud computing. If you really want to run massive data set, do massive data processing, this is the way to go. And you can stream the data on the fly. You can run computation. You can get the result. You can do all kinds of things. And so if this is what you want, for example, after you select the FC, so the FC right now is only, for example, Florida. So if I run this one here, FC, and if you just see it, it should be able to show you the result. For example, this is the feature collection. Inside, you only have one because we already filter. We already filter the data set. So right now, this is on a single Florida. You can see the population, you can see the area, you can see all kind of attribute from that. You can turn it into a dictionary. So one thing I want you to understand is, so all the Google engine computation is called a server-side object. So server-side object, that means the variable is pointing to something in the cloud. It's not on your computer. Compared to our traditional Python programming, for example, say x equal to 1. Okay. So for example, for this one, x equals 1. And then I can just print out x here. Make sense? So this is called client-side object. Client-side means the variable stored on your local computer in here is not in the cloud. But compared to this one, for example, this feature fc.first, this one is server-side object. So I will say print fc. Oh, no, fc. Look at this. This one doesn't really make sense. It says feature collection and then function, compute, blah, blah. This one is basically just instructions. Instructions how to compute this one. And it doesn't really tell you what's actually inside unless you say you print out you just type the variable or use the .get info. You see, this is probably too much because there are too many vertices inside, so it actually frees my computer. Oops, see, it's gone. So the differences between client-side object and the server-side object is client-side usually stored on local computer, so it's much faster to access it. But the resources is going to be limited based on your computer hardware. If you have a very old computer, you're not going to be able to handle large amount of data. But for the server side, you can do a lot of computation using the server, and it's going to be much more powerful. To make sure you understand the differences between client and server, it's essentially like to watching a movie, okay, using a cell phone. You can record a video using a cell phone and then can play the video, but your cell phone only has a limited amount of storage, right? And you cannot just play a 4K video or 8K video on your cell phone. But you can stream Netflix 8K, 4K video. It's streaming on the fly, and you can still see very clear on your phone or on your laptop. And your laptop doesn't have to be super powerful. You can still watch the 4K video because it's only streaming a small portion when you are watching it. It doesn't have to download the entire file all at once. And this is you don't, but it's called server side because you don't really have access to the original video file. You are watching it, it has been changed to a different format. So you cannot really download the video from, for example, from Netflix. Of course, there are some illegal ways to download the video from YouTube and other streaming services. But that's the whole idea, is that you don't have to worry about what's the format of the video. Is it MKV? Is it MP4? Is it AVI? You don't have to worry about that. It's just a video. Your goal is to just watch the video, right? But if the video is on a local computer, you know everything. You know the data format. You know everything. So this is essentially what Google Sensing is about. Is that it has a huge data catalog. You can do anything you like, but you're not going to see all the data all at once. You can filter the data, you can get access to the data, but you don't want to basically download the data directly to a computer because it's on the server. Okay, so here I can also, for example, filter the data by a list. For example, if your name is somewhere in California, Oregon, or Washington, I can select. So this is called select by attribute. So if you kind of similar to desktop GIS, you open the data and then you select something by attribute in ArcGIS, QGIS. You can do this one. So Google Sensing doesn't really have a user interface. You need to write everything using Python script or JavaScript. But it's super powerful if you know how to do it. So for example, I can select the data for example, for Southeast, or I can do it somewhere. For example, okay, I want the data for this area. So pay attention. For example, I want to select the US state intersecting with my bounding box. So can I do that? I don't need to change the call, so pay attention. Okay. It's just instant. So all I need to figure out, okay, if do you do anything on the map? If yes, I'm gonna use your reason. And then all we need to just filter bounds. Filter bounds basically is select by location. So you have the entire data set. If they're intersecting with my area, I'm gonna select this one. And then I'm gonna add the data layer to the map, and that's it. So very simple. For example, okay, I work on the northeast. I want select all the states, in this area. Right, so I draw a kind of rough outline, and then just run this code block and see how powerful it is. So if you know how to do the coding, it can save you a lot of time because it's the same source code. All you need to just change the input slightly, and then the output will be updated automatically. So you see, I don't need to make a lot of changes. So you can easily adapt this one to do a lot of other computation. And you can also clip to a collection. For example, if you're working in a particular region and you want to get the data, then you want to, clip the imagery to a certain location. You can do that easily like this. So for example, this is the code block trying to visualize the data, landscape data for a particular country using this false color composite, right? So if you're working on some other country, for example, I want the data for, how about this? Okay, I want the data for Brazil, right? Simple and easy. BRAZIL. And I don't need to change anything else. Just take a look. See, I can have data right away. So you can clip to the global data set just by simply changing this one. And everything else remain the same. So it's super, super powerful, and make sure you utilize this. For example, I want Mexico. Okay. I have Mexico. So going forward, If you ever need any satellite imagery, you ever need any vector data or something, try to think about how do we um, use Google Sensing to help that. And everything that we have covered so far, these are all built on top iPi leaflet. So if you really want, I can show you like under the hood how do we actually add the Google Sensing data layer to the map. So if you look at this, this is right now the satellite imagery, but under the hood you can see the dock layers. As I have shown you before, everything you added to the map is some kind of layer. So this one is the tile layer, and if you scroll down all the way to the right, look at this one. So this is actually the URL generated by Google Sensing, and you can see this one have at the bottom, at the end here have like XYZ blah blah. So if you really want like, okay, how do I actually integrate this one into my package so that I can use it? It's actually very simple. If you can find a URL from somewhere and that URL contains some data, you can actually load the data into the map. But this one, the only thing that's quite different from other web services is Google Sensing. This URL is only valid for 24 hours. After 24 hours, you have to rerun the code to generate the new one because it's not permanent. So Google Sensing generate the data on the fly. For example, earlier this is the data set for the entire globe. I only cut this one for Mexico, but they don't save the entire data on their server. It's temporary, so it's running all the computation and then just doing all the stuff and giving you the URL. So if you come back again tomorrow, this URL will not show any data. But if you really want, for example, GeoDev, I might need to, yeah, I forgot, I haven't installed this one yet. So let me quickly show you like how to actually integrate some of this into your package. So let me show you here. Because it's built on top iPi leaflet, so anything that's iPi leaflet, you can actually utilize that. So now let me show you here on the activate geo, okay, git pull, and then pip install -e area. Once I have this, I can show you how to actually utilize this one in our package. So here, you can come back to this one. I can just simply copy this URL. All right, Control C, and then run this one. All right, then I can import my package. Import geodv. Oops, I think I need to restart the kernel. And run this one. Really? Already installed it. What is happening? Oh, it's already installed. Let's know. Maybe just close it, save it, and then we open it. So what I want to show you is anytime if you see anything, if this built on top of a package that you already familiar, you need to know like what's the pieces. And then once you know the concept, you can add this one to your package. Just like now if you see any iPad widget, you know, okay, this is the drop down list, this is the button, and you try to figure out, okay, how do I reinvent, put this one into my package. So let me show you one more time here. Okay, it's over here. Still not working? Okay, it works now. I don't know why earlier it didn't work. So here, for example, geo.dev.map, right? So right now, this is my package. And so earlier I showed you like Google Sensing generate this URL. It's a simple URL. So I can just run this one. And then from here, I can just map.add. I have the tile layer function. Map.add. I already have the tile layer. Yeah, if not, then you can use iPi leaflet. So for example, I can do here from iPi leaflet import tile layer. right? Pi, huh? Oh, import GeoDB. I delete that one. Any typos? Hmm? Pi leaf. Okay. Okay. All right. So once I have this tile layer, now I can just simply I can say, okay, layer equal to tile layer, and then you can pass in the URL equal to the URL. All right. And you can give a name, attribution, blah blah, whatever you like. And from here, I can just say add layer. And hopefully, you see, I can load the data into my map directly. So now this is mine. This is exactly how Gmap actually built on top of iPyLib that. Although I don't have a lot of buttons and other stuff, but it's the same thing because this URL is the URL that it's a standard one. It's called XYZ type URL. So if you see a URL like this, blah blah, and then at the end have like XYZ. XYZ means X and Y basically is the latitude and longitude, basically the center of the map. And the G is the zoom level. So iPyLib understands how actually depends on the location, it knows which one to grab. So you can use Google Engine as a server to actually render the URL and then you can load it to the map. And now show you quickly. For example, if you go to my GitHub, I actually have a couple Earth Engine data layer. I will show you here, just to know how I use this one to actually is kind of a workaround. Use Google Engine as kind of server to generate the URL. So I have this, for example, data set here. I have a couple sample data sets. So if you look at on the right, these are all the URL that I use Google Engine to run. And then I rerun this script every 24 hours. So that the URL is always valid. So if you want, I can try out some of these data set. For example, I want maybe the USGS 10 meter resolution DM. So this one is like many terabytes. And I can simply just copy this URL. Let's see what happens. So this is the so-called URL. So anytime if you want to add some web services, you need to add either it's a WMS layer or it's an XYZ layer. So right now I update this one and let's see what happens. Oops. I need to construct the layer again and then run this one. And hopefully it's going to come up sometime. This is a huge data set. This is the DM 1 meter resolution for the entire US. See here, I can load the data, I can customize it. It's going to load it on the fly onto my computer. And it's using their data catalog, 1 meter resolution. It's transformative. If you try to download this one to a computer, it'll take you weeks. I can load the entire data set. It's very high resolution. It's very detailed. You even have the hue shade, for example. Let me see if I generate the hue shade. Yeah, so for example, 1 meter hue shade. So you can have the DM, I can run the hue shade, and then I can just load it directly onto the map. And you can see how detailed it is. This is not something you can do using traditional computation. So run this one, and then import the map, run this. Now this is using my package, okay? This is not using any other packages. It's just using the Thai URL and zoom in. See how detailed are these data set. This is 1 meter resolution data set, and then just creating the hue set on the fly. Besides that, there are some others. For example, global land cover, or even just the building, something like that. So if you're working on something you want to utilize the land cover data set, I can use this one. Just copy the URL and then come back to here. Right. And then run this. So now I have the global land cover data set, 10 meter resolution loaded onto the map directly. And there's no really much you need to do, right? So now you basically all you need to just get the UI. So if you can get the UI, you can load this one to your package, right? Everything else is nothing new. It's import your package, create the tile layer, and then just add the layer. Or you can even just make it easier. Just add, for example, create a new function called add tile layer, and then just passing the URL. Then you don't even need to import this one. It'll be just your package. Super easy. Okay, any questions? All right, so this is about how do you integrate Google Sensing into your package. And we don't really have time to go into the entire notebook. You can spend some time, you can go through that. I want to actually showing you what kind of things you can do with Google Sensing and also iPy iPy widget. But I want to go through, maybe go to the other section that's more interesting so that you can export this one yourself. If you go to I'm gonna skip all this, okay? You can do that after class. We don't have any assignment for this. I want to go to the create time-lapse animation section. So this is the one that's super fun because you can try it for any location around the globe. So I'm gonna use Google Sensing to create, for example here, I'm going to select an area around Las Vegas and I want to create some animation. So let me show you here, just one line of code, Geemap.lensset time-lapse animation. So this one allows you to create animation for any location on the globe using any satellite data time series. And it's a lot of data processing involved. It usually takes maybe 20 to 30 seconds. Then you have the animation. But the nice thing about this is you can do that for any location. And think about like we have satellite data from back into the 1980s up to the current date. And for each location, you're going to have a lot of satellite data covered throughout the year. It can be 20 images, it can be 30 images, and not all the images have the same spectral bands. So you need to download all the data, remove the cloud, and then standardize them, and then try to create a simple animation. And take a look at this. Can you see the urban growth in Las Vegas? This is probably the fast growing city in the US. So I have the satellite data from the 1980s all up to right now, and I don't need to really download the data myself. You can ask Google Sensing, okay, these are all the data. This is the area of interest that I want, and I want you to create the animation for this location, and this is the band combination I want. And all you need is just one line of code, Gmap.lensset time-lapse. It can be any location that you like. It doesn't have to be the one here. But the easiest way that I can show you, you see how powerful it is. I just create a map. Okay. So for example, this is using Gmap, just like you create a map using your package. But I'm going to go to maybe somewhere here in Plu. Okay. For example, this. They say, okay, I want to see the changes of this location. You can certainly, yeah, you can change the base map. So I can change, for example, to satellite, right? Something like this. And I know, for example, if you're studying rivers and hydrology, I might be interested in looking at some of this area. So what you need to do is very simple. I have the draw control. I can maybe just look at this area. All right. Something like this. And then I can just click this button, upper right corner. All right. Click this. And now pop this one up. You know how this was created? Do you know all the widgets right now showing up in here? It's just a simple iPy widget. This is a composite. So for example, for this one here, I can select what band you want to use combination. We use Lensset, and then from 1984 to 2025, I want to use the data from months of May to July, and I also want to extract the water. So for example, I can select this one, and this just try it out. Don't do anything else. There's no coding behind the scene. This one is hundreds of lines of code, but it's basically grab the user input. So what I'm saying is, okay, Google Sensing, I want to create a time-lapse animation for this location, and I want the data from the earliest 1984 to right now with almost how many years? 40, 42 years of data. And so for all the data that cover this area from May to October, you're gonna get all the data, and then you're going to mosaic them. You're gonna process them so that they are consistent. And then I also want to extract the surface water using the normalized difference water index, using the green band and near infrared band. Okay, look at this. No coding. How cool is this? And you do the local computation. If I ask you, I mean, without cloud computing, I ask you to create this animation just for this location. Imagine how long it's gonna take you. I can guarantee you, you cannot really create one like within couple hours. It might take you several days because you need to download all the data for your area, and then you need to create a cloud-free imagery for every year, right? And then you're gonna put it all together. It looks very simple, but it's not. Okay, it's taking a lot of time and computation. So with this, how cool is this? I can even remove this one. I can zoom in actually. Animation is overlay on top of the map, on top of the base map. Can you get an animation to the map? You know how to do that? Do we have a lab assignment about this? Add image and then add a GF animation. Remember? And then have the bounding box like coordinates. This is exactly like that. This is using that simple function that we cover. But of course, you need to do all the computation. You need to run the data. But see how cool is this? I can even do it like this. Can you see the river channel changes? And the Ospo Lake. So if you're doing like starting this kind of river channel, I mean changes. I mean, there's nothing better than showing the animation of the real dynamic, and it changes really fast. And not just for like getting the original image, I can show you the animation, just extract the water. So you can calculate how much water actually every year, and you can really see the dynamics. And imagine, this is just the water. It can be anything. It can be rivers, it can be buildings, it can be vegetation, it can be agriculture, it can be anything. As long as you can have the algorithm to compute, then you can use the data. So think about the data. You don't really need to download the data. You just tell them, okay, I want this data, and this is the equation I use to extract the stuff, and then just create the animation for me. And within 20-30 seconds, you get the result. And then if you really want, you can just download this one. So the link here, click, and you can download this one to your computer. Similarly, you can download this to your computer. And this is not just for this location. It can be anywhere. Like I said, it doesn't matter where you are. Any location that you're interested in, you can do it like this. So for example, I may maybe go to you can try these ones out. For example, maybe how about this? I know there's a city in China. This one is like very fast urban growth in this region. So if you really want, maybe I can show you somewhere here. How over here? For example, I guess there's a lot of growing here in these areas. These are called like actually fish pond or something like that. And there are a lot of changes in this area. And I can just simply maybe zoom out a little bit to zoom out. How about this? Okay, so I know, okay, there's a lot of growth in the past decades. I want to see the changes in this area, and let's see what happened. Same thing, there's not really much you need to do. Just use the same GUI, and then again, you can see the water changes if you want to, but let's see what's going to come up. Of course, you need to wait. So imagine how many images involved under the hood. There are hundreds, thousands of images. And for every year, it's going to grab all the images for the year, and then going to create, for example, remove all the cloud, and then create a median composite. And after that, it's going to basically generate animation. See this? Oops. And let me turn this one off so you can see. And you see in the first couple of years, because they are not a lot of data, so that's why you see some dark area. So you can actually switch this one to maybe to a later one. For example, 1990s. But look at this. You see those agriculture, and then like urban expansion, there all the vegetation, all the agriculture, that slowly they're gone. See here, this here. See the agriculture, the green one, and then it become fish pond, like the entire one. So this is all basically what's that called? Horticulture or something, like growing the fish, shrimp, all kind of seafood stuff in here. And this is just like watching your child growing couple decades, see how they changes. Oh yeah, here. If this is too fast, you can change it. So this one is a speed here. Where is it? There should be 1 frames per second. So if you want it slower, for example, 10 frames per second, that means every second you have 10 images, 10 years. If it's too fast, you can change it to like one frame per second. Then, because this is 40 years, the animation going to take 40 seconds to finish. So it's up to you how you want to control. But this is super powerful. And like I said, I can just extract the water so you can see the changes of the water. Like at the beginning, there's not really much, but after that, you can see all the those fish ponds going up on the imagery. And again, try it out for any location. All you need is just 2 lines of code. That's it. And you can create animation for any way you like. You can even change the visualization. So right now, I only use for example, the force color composite, but there are so many other those available. And you can change the year, you can change the day, you can change the time, you can change the text. And so you can showcase this one for changes for any location around the globe using the satellite data with almost more than 40 years of archive. All right. So this for Lancet, but you can also have Sentinel. We don't have time to do all that, but I can show you the other one. For example, you can also customize the exact area. Oops, I need to do it. Maybe this one. So you can actually customize the area. So you can just only just a bounding box. For example, what's the location? Bounding box for location. Oops. For example, for this one, and then let me show you here. So this one is the Hong Kong. For example, they have the airport and also I think the Disneyland somewhere here. But it doesn't matter. You can just open the map, just create a map, and then just draw a rectangle, and then just use that toolbox. Just one button, and then you can create. It's super fun. So you can explore changes for any location around the globe in the last 4 decades. And Lancet has the longest data archive that we have. It's something that you won't see from other data. Okay, you see, 20-30 seconds. I can see, and so they see this is the airport, right? Built around, I think, year 2000. And you have this, and also somewhere here, or in the 90s. And this one is the Disneyland they created. Probably take what time. You need to slow down the animation to see when they start naming the changes, but it's global. It's anywhere that you like. So try it out. And similarly, there are some other animation data sets. So not just for Lancet. Geemap can create animation for any location that you like. So for example, I'm going to use what vegetation. So I'm interested in studying the vegetation changes at the continental scale. And this Geemap has this function called modis NDVI Timelapse. You can specify the date, the start date and the end date. You can specify what spectral band you want to use. So I'm going to use the NDVI. They also have EVI and then different satellite. And after that, within 10 seconds, you have this. Have you seen this on the internet sometimes? If not, you can create one by yourself. It's super fun. You can see the vegetation changes throughout the year at the continental scale. You can see how dynamic it is. So during the summer, right, we have the sun in the north. And during the winter, it moves to the south. And see how the vegetation actually changes throughout the season based on the season. You can do temperature. I don't have time to go into detail, but the last one to show you is besides those coarse resolution data, we also have a lot of weather and weather satellite that capture the data in a high temporal frequency, but it's much coarser resolution. So if you're studying climatology, weather, something like that, this can be something useful because it can capture the data very, very quickly. So what's this one? Know what's this event? Volcanic eruption. It's the Tonga volcanic eruption in 2022 and January 15th. And this is something being captured by satellite every 5 minutes. So you have one snapshot. So you can capture them all together. There's nobody in space just there to take the photos like manually. We have those satellite operational. And then you can just, because Google Sensing has all the data. So only to figure out, okay, what's the start and the end date? And then what's the area of increase? Then you can use that to create animations very, very easily. So the last one, I want to show you here a couple more about hurricanes. It can be hurricanes, tornadoes, it can be anything. So it's you need to decide what data you want to use and then decide the time and then show the area, and that's it. Once you have this, you can use Google Sensing. So Google Sensing has pretty much all the data, all the public available data in the public domain, and you can use it to run computation. If you have to, like I said, if you have to do this one manually, good luck. This simple animation can take you hours to actually to download and then compute. And so, for example, you have any hurricane event, now you know, right? You have maybe have seen some of this on social media, on TV. Now you can create this by yourself. So only to figure out what's the date, start and end date, what's the time, and find a suitable data set. Then you can generate animation. Basically, they can create this one very, very quickly. Okay, so that's all for this lecture. Like I said, it's a very brief introduction. There are a whole lot more. I can teach this one a whole semester just using Google Sending, but I want to give you some flavors just to show you what kind of things you can do with cloud computing. And that's all for today, and I will see you on Wednesday.